In this video, I'm going to show you a new pattern in React that you can use that is very, very powerful. Check out this example. So over here, we are running a Next.js application and we have a couple of tasks that are all asynchronous. If I refresh the page over here, you're going to see that each task gets executed one after the other. Now, what if I told you that all of this is happening entirely on the server and that there's no concept of useState, there's no useEffect, there's no fetching going on or any sort of polling that you would otherwise expect. This is completely driven by server components. But not only that, if I come here and open up the console and actually refresh, you're going to see that each one of these tasks over here receives as an argument the return value of the previous task. So as you can see here, we have user1 named John Doe. Here in this one, we have user1 named John Doe as well. That is coming from the previous one. And then we have some extra properties over here like process data and stats. You're going to find them in this task over here, all the way to the end where we have this task over here that has all of them. This is all, once again, completely run on the server, and it's a really, really cool pattern. I'm super, super excited for this video. All right, so before we get into the code, I do want to give credit where credit is due. This is actually not my pattern. I did not come up with this idea. I got it from this blog article over here written by Nico Pranata. This is a very, very good read. I highly recommend it. And also, I have been reading his other blog articles. They're equally as great. I highly recommend to check out this blog in its entirety, but also specifically this article because it is phenomenal. And you should honestly also check out Import React, which is my free newsletter, where we actually sent out this article a couple of weeks ago, and you can get more of these articles delivered to your inbox completely for free every single week. And if you're curious to see what kind of things we posted about in the past, you can see all of our posts here from the past. I highly recommend this. This is the best resource to keep up to date with everything that is going on in the React world. If you're interested, once again, you'll find a link in the description of this video. Cool. Now with this, let's look into the code at what is driving this entire really cool application over here. All right, cool. So this is the code. This is a Next.js application, which means that server components are the default. And that's what this page component is. It is a server component. All that this component is doing is it has one function call to this function over here, unsafe create sequential processes. This may look like a hook just because of the signature over here, but don't get confused. This is a function and this lives entirely on the server. This function receives some arguments over here. We have a bunch of processes that we're passing to it, and we're passing specifically the execute function of each of those processes. These processes come from this variable over here, which we're going to look at in just a moment because it's also where our create sequential processes function also comes from. And then we're passing all of these things to our step components over here, which also receive a title and a description, which also comes from each individual process. And then the return values of this create sequential processes function, we pass as the work property of the step component, right? So we have the first, second, third, and so on. So let's look at this unsafe create sequential processes function, right? So first of all, don't mind this unsafe over here. It is completely safe to use. The only reason why the author put unsafe over here is because they couldn't figure out a way to properly handle the TypeScript types. As you can see, we have a bunch of any's over here. And so if you use this function, chances are your types are going to break. And so he thought it would be a good idea to put unsafe, which I agree. But otherwise, this function works exactly as you'd expect. Now, this function over here takes a list of processes as its arguments, as we've seen when we called this function. Now, there is a distinction here. There's a distinction between the first process and then all the other processes. The only difference is that the first process actually has an optional argument of type any, and all the other ones have actual arguments that, as you've seen, come from the previous process in this list. All of them return promises over here, which means that they are asynchronous and need to be awaited to actually get the value. And then what we're doing here is we have this really clever piece of code over here that simply uses a reduce from JavaScript, and then essentially will call each process one after the other and then feed the arguments into the other process. So the way that this works is if we're on the first process over here, well, we're just going to call the first process with undefined, no arguments, that's fine. Then on each subsequent iteration, we're going to take the accumulator over here, and then we're going to spread it into a new array. And then as the next element in that array, we're going to take the last element in the iterator, so the last process that currently ran, and then we're going to take this dot then over here, we're going to apply it to that process, and then we're going going to call the process to it. And this is going to pass the arguments of the previous process into this new process. This is really clever. And this is using nothing but a simple JavaScript reduce function. Really, really love it. So that's what's happening here, right? We have all of these processes. This is our first one. It doesn't take any arguments here, but we just passed it a hard-coded value of a user ID of 1. And then for each one, right, it takes in the arguments, the return value of the previous process as its arguments, and then executes its function and then passes it to the next process. This is really clever. Now let's look at these individual processes over here to just see what the functions actually look like. So we're going to go back here. We're going to go to the top of the file, and here we have some types, right? Because we are working in TypeScript. So we have this user data over here, just has a user ID and a name property, nothing fancy there. Then we have process user data, which is our first process over here, process user data. This one receives here the user data and then returns alongside the user data, returns some extra variables like process data, some stats, and so on. And then we're doing the exact same thing with the enriched user data over here. It receives the process user data and then returns these extra variables over here. And we're doing that for all of the other processes. Each process is just defined inside of an object. So we have fetch user data, we have some title here and a description. This is going directly to show in our UI. And then we have the execute function, which receives, in this case, the user ID, returns a promise of user data, and then just does some set timeout over here to resolve the promise with user data. And then we're doing the same thing here for process user data. This one receives user data as its argument, returns a promise of process user data, and then does the exact same thing, right? All of these are doing essentially the same thing. And note here that these timeouts, right? This is 1 second. This over here is also 1 second. This here is 1.5 seconds. This one here is 3 seconds. And this one here is 2 seconds. If this was all happening in parallel, which, you know, it isn't, then what would happen is after 3 seconds, which is the length of our longest task, all of these should be done, but they're not. They're happening sequentially. So each one is waiting for the previous one to finish before it can use its return value as its arguments and then execute its function, right? So these are sequential. Now, all of this is really cool, but that's not the pattern, because all of this has nothing to do with React whatsoever. The pattern, and now we're going to get into this, is also very clever. So there's two things that I want you to focus on. The first one is that over here, when we're calling this function to create our sequential processes, we are actually not awaiting this function at all, right? We're not doing any sort of await. Even though we could, because this is a server component, we're not doing that. We're just creating the individual promises themselves, and then we're passing them here in these variables, first, second, third, fourth, and fifth. And then we're actually passing those promises over here. So you can see this is of type promise. Yes, unknown because we are losing the types, that's fine, it's still a promise, and we're passing each promise as the work property of our step component. So we're not consuming the promise in this component, instead we're passing it to another component through props. That is one step of the pattern. Then if you come here and open up the step component, this is another server component, so there's nothing here on the client. This one receives the work, the promise, as its props, and then passes it here to this asyncable component, which is wrapped in a suspense boundary. So if you don't know, a suspense boundary essentially takes a part of the subtree of the component tree of React and wraps that part of the tree in React. And then if there's anything asynchronous in there that is going on, it is going to suspend that part of the tree. So it's going to unmount those components, show a fallback over here until that promise is done, until the asynchronous work is done. And that's what we have here. We have a suspense boundary, we have this asyncable component over here, and then we have this fallback, which is going to be a step icon of in progress. And then if we're not in a suspense, so if the promise has resolved, we're going to show here a step icon with status of done. So this is just two step icons with different statuses. Usually in a client component, you would do this through state. You would have a state property is loading, and then you would update that state property whenever the asynchronous work is done. And then based on that, you would show the appropriate status. This, on the other hand, is all completely done on the server, and there's no concept of state here. The server is automatically handling all of that for us, which is great. And then we have this asyncable component over here, which I lied. I'm sorry. There is one client component in this entire code base, and that is this asyncable component. We have here use client at the top. And what we're doing here is we're receiving the work, the promise as props, and then we're using the new use hook from React to actually consume that promise on the client. That is what this hook does. You can use this hook to actually access a context, or you can use it to consume a promise, await it, and get its value, and then actually trigger the nearest suspense boundary to show a fallback until that promise has been resolved, right? So this is like very clever. We have here in a server component, right? We're creating our promises, and then we're not awaiting them. We're instead passing them through props to components to another server component, which then passes it to this client component, which is going to consume this promise, resolve it, await for it to return some values. And then while that's going on in the server component, we wrap that asyncable component in a suspense boundary. The fallback is shown, and that automatically handles all of this changing of states for us without us having to do it on the client manually through useState. And then over here, we have the same thing with the title. We have a separate suspense boundary, a separate asyncable component. And here we're rendering the title once we have the value. And then if not, we have title disabled true, which I believe is just going to set the opacity. I think, yeah, it's setting the opacity here to 50. While this disabled boolean is being true, right? So it's a very simple component. Also important to note that this asyncable component over here receives some children over here, right, as props, which are server components. This step icon component over here, if you go to this definition, this is a server component, right? You can pass server components as children to client components, wrap all of those in a suspense boundary, and then show a fallback until the asynchronous work is done. This is a really powerful and really cool pattern that you should now use when working with React, right? So with this, we have something that looks like this. It looks like their state. It looks like it's interactive, but it's not. It's completely on the server, and we have no manual setting of states, of fetching, of useEffects, of any of that going on. Can you just imagine the code required to actually do this if you were using completely just client-side React, right? You'd have to have so many state variables, so many useEffects, so many different mechanisms to actually fetch the data, and then wait for the previous process to actually finish before fetching the next one. And then also passing the data from the previous one to the next one. It's a mess. This way, we just have one function, one component, a few of the suspense boundaries, and then one client component that asyncs and awaits the promise, and we are good to go. So if you're working in server-side React with server components, absolutely use this pattern instead of using useState and useEffect everywhere. I promise you, this is better, this is faster, this is a better user experience for a user, it's a better developer experience for you, there's less code to manage, less complexity, and you just let the server and the framework do everything for you automatically. So there you go. That's it. That's all I have for this video. If you've enjoyed this video, make sure to leave it a big thumbs up. It would really be appreciated. You can also click here to subscribe, which you should. It's totally free. And come on, why not? This is great content. Or you can also click here to watch a different video of mine that YouTube seems to think that you're really going to enjoy. And with that being said, my name has been Darius Kozin. This is Kozin Solutions. Thank you so much for watching, and I will see you in the next video. Ciao, ciao.